Hello, so today we're going to look at the vector and parametric equations of a plane. All right, so I have them written down over here, the formulas, the equations. So for the vector equation of a plane, it looks very similar to the vector equation of a line, except we have two direction vectors. Now the parametric equation of a plane, very similar to the parametric equation of a line, except now we have those two direction vectors and their coordinates incorporated into the parametric equations of a plane. All right, so we're going to keep that in mind and have a look at the following questions. So a plane passes through points P, Q, and R. Use PQ, vector PR as direction vectors, and write a vector equation for the plane and a parametric equation for the plane. All right, so first step, let's find these direction vectors, PQ and PR. All right, so PQ equals Q, equals Q minus P. We have 2, 3, negative 2, minus 2, negative 3, 1. What does that equal? 2 minus 2 is 0. 3 minus negative 3 is 6. Negative 2 minus 1, negative 3. That's our first direction vector. Second one is PR. R minus P. Then we have 0, 1, 1 minus 2, negative 3, 1. So this equals negative 2, 1 minus negative 3, which is 4, and 1 minus 1, which is 0. So let's label these direction vectors as N and M. Okay. So number one, or part A, a vector equation for the plane. So we need to fill in this equation. Well, we can pick any one of our 3 points as our point on the line. So let's pick P. P is as good as any. So we're going to have 2. So we have our coordinate vector for P is 2, negative 3, 1, plus T times our N vector, which is 0, 6, negative 3, plus parameter S times our M direction vector, negative 2, 4, and 0. That's our vector equation for the plane. Now B, our parametric equation of the plane. Let's give ourselves some more space. So we're going to just take this vector equation in part A and break it up into its components. X equals 2 minus S, Y equals negative 3 plus 6T plus 4S, and Z equals 1 minus 3T plus 0S. And again, our T and S are real numbers. We'll just put that in for our vector equation of the plane. Good. All right, next question. Find the equation of a plane that contains the point P and line R. All right. Okay, so this is interesting. So we have a point and a line. So let's call the line L, just L. We just have one line. Our point and our L. So for a plane, we need 2 direction vectors. Well, our line gives us 1, so let's call that M. We have 1 direction vector, but we need a second one. So how can we get a second one? Well, we have a point. What can we call this point? R0 on our line. What if we find the direction between our point on our line and our point P? Let's call that direction vector n. Then we'll have two direction vectors. So why do we do this? So our direction vector n equals r0 times p, or p minus r0. So let's figure out what this point is. 2, negative 1, 1 minus r, 1, 3, 2. So 2 minus 1, 1. Negative 1 minus 3, negative 4. And 1 minus 2, negative 1. That's our second direction vector. Okay, so it looks like we have all the components. We have our point on our plane, our two direction vectors. All right, so therefore our plane is our point P, which is 2, negative 1, 1. So it goes through the point P, plus our first direction vector, which is 5, 1, negative 2, plus our second direction vector, which is 1, negative 4, negative 1, and of course S and T are real numbers. Good. That brings us to the end of our session today. If you have any questions, feel free to send us an email at info@raisedbymarks.com or give us a call day or evening, and we'll be happy to answer your questions. Thank you for watching, and we'll see you soon.